All right, so today we're starting with spread B, which looks at the structure of the brain and the four lobes of the brain. So last class, we actually went through what the brain was. We looked at some of the key features of the brain. And one of the key characteristics of the brain is that it is comprised of an outer layer or an outer cortex that is known as the cerebral cortex. The cerebral cortex is basically the part of the brain that you can see without having to go in and dissect it. It's the part of the brain that you can see on the outside. It's basically the outer covering of the brain. And so on that outer covering, on the surface of that outer covering of the brain, you've actually got four lobes. Okay, and each of these lobes has a specialized function as well as other additional functions that it's associated with. So you've got your frontal lobe, you've got your parietal lobe, you've got your occipital lobe, and you've got your temporal lobe. Okay, those are the four lobes of the brain. So it's important for you to know their names. You can use the memory tip FPOT to remember that those are the four lobes of the brain. Okay, so the frontal lobe of the brain is called the frontal lobe because it's right at the front of your head. In fact, if you feel your forehead, literally just behind your forehead, that's where your frontal lobe is. Okay, your parietal lobe is literally at the top of your head. So if you feel the top of your head, your parietal lobe would be directly underneath that area. The occipital lobe is at the back of your head. So if you feel the back of your head, that's where your occipital lobe would be located. And your temporal lobe is located on either side of your to be above and around each of your ears. So obviously, if you feel above and around each of your ears, that is the region where you would have your temporal lobe. Now, we know that we've got lobes on each side of each hemisphere of the brain. So you've got the frontal lobe in the left hemisphere, and then you've got it on the right hemisphere as well. Okay, so like we said last time, the brain is divided into two hemispheres. Okay, so you've got your left frontal lobe and your right frontal lobe, your left parietal lobe, right parietal lobe, left occipital, right occipital, like that. Okay, so just remember that this is just a diagram just to show you and give you an idea of what the different areas that these lobes are located in. Okay, in terms of what this kind of tennis ball looking structure is at the bottom, we're not going to learn about that this year, but it's actually the cerebellum, and the little stick that's kind of sticking out from there is the brainstem. So we'll learn more about those if you're going to continue to do psychology next year. If you're doing Unit 1 psychology, you'll learn more about those structures. They mainly play a role in balance and consciousness and that kind of stuff. Okay, so we don't need to worry about those two structures, but just knowing the four lobes of the brain. Okay, it's really important to know the locations of the four lobes, mainly because sometimes in a question we might give you some information like this person has gotten into an accident where they've been struck at the back of their head. What symptoms are they likely to show? So if we go back to this particular diagram and we see the different lobes of the brain, and if someone is struck at the back of their head, we know that the occipital lobe is the lobe that is most likely to be damaged because that's the lobe that's located at the back of the head. So knowing the functions of the occipital lobe, we can then conclude that they might experience specific symptoms as a result of damage to that lobe of the brain. Okay, so as we're going through the different functions of the lobes of the brain, this is something to keep in mind. I've already talked about the fact that the cerebral cortex is the outer covering of the brain. It houses the majority of the brain's lobes as well as the brain's neurons. Yeah, I already explained this in the previous slide, so we'll keep moving on. So the first lobe that we're looking at is the frontal lobe. As I said before, the frontal lobe is located at the front of your head, just behind your forehead. So just behind your forehead, in your cerebral cortex, you've got your frontal lobe. Okay, the frontal lobe is important because it contains the primary motor cortex. Now, the primary motor cortex plays a really important role in movement. Okay, so basically, when we're talking about movement, and I mentioned this last class as well, we talk about this idea that sensation and movement occur in a contralateral way. Basically, the left side of the brain will control movement for the right-hand side of the body, and the right-hand side of the brain or the right brain hemisphere will control movement for the left-hand side of the body. So like if I want to pick up my water bottle with my left hand, it's going to be the primary motor cortex in my right hemisphere, in my right frontal lobe, that's going to be responsible for that. Okay, so that's the basic idea. Okay, contralateral. Contra means opposite. Okay, and we hear the word contra in things like contrary to popular thought. So contra means opposite, lateral means side. So contralateral is literally defined as on the opposite side. Okay, so that's contralateral organization. Cortical representation is this idea that certain parts of our body, because we know the frontal lobe has a really big role or major function in movement, when we talk about cortical representation, we're talking about what parts of the brain have a larger amount of space dedicated to them in terms of dexterity. So dexterity is about how easily you can move a body part. You might have heard of the word ambidextrous. Does anyone know what ambidextrous means? Have a guess. If you know, put it in the chat box. What does ambidextrous means? Yeah, able to be used by both sides. When you're ambidextrous, it means that you can like use both hands to do something, for example. A lot of us can't write with our left hand if you're right-handed, for example, but an ambidextrous person can write with their left hand as well as their right hand. Okay, so dexterity is about how easily you can move a body part. Now, if you think about it, certain parts of our body we can move a lot easier than other parts. For example, it's a lot easier for me to move my fingers or move my hands compared to moving my arms, okay, compared to moving my knee. Okay, so that's because there's more representation. Cortical representation is another way of saying there's more neural space, or in other words, there's more space in the brain dedicated to body parts that require to be moved a lot. Okay, so neural space or cortical representation or cortical area is just referring to this idea that body parts that need to be moved to a greater extent or need to be moved more often will often have more space dedicated to them in the brain. Okay, so that's what the primary motor cortex is about. The primary motor cortex is the specialized area of the frontal lobe. There are also other functions of the frontal lobe which we'll go through as well, but just remember that the main specialized function, okay, is movement. You will never forget this because we know that the main area or the specialized area of the frontal lobe is primary motor cortex. And whenever you hear the word motor, you think about motor responses, okay? You think about motor functions, motor skills. Motor skills are related to movement. So you should not forget that. My voice is cutting out. Oh, that's weird. Wonder why that's happening. Is it still cutting out now? Better? Okay, I don't know why that happened. That's weird. Okay, hopefully it doesn't happen again. So that's basically what the frontal lobes are about. Okay, just remember, frontal lobe contains the primary motor cortex. Primary motor cortex is responsible for movement. That's the primary function of the frontal lobe. What about the other functions of the frontal lobe? Let's have a look. So just before I go, I want to show you the other functions. We use this memory chip called Pamper Pets to remember some of the other functions, including movement as well, but some of the other functions that are the responsibility of the frontal lobe. So we can look at functions like planning, attention, problem solving, reasoning, experiential learning, which is learning from your experiences, personality, emotion, temperament, which is basically how quickly or how slowly you get short-tempered, and spontaneity, which is about how spontaneous you are in terms of how quickly can you do something at the drop of a hat. So those are the other functions. You don't need to know all of them, but just maybe along with movement, you need to know movement, that's the main one. Along with movement, just maybe know at least 3 more functions of the frontal lobe. Okay, that should be enough. So altogether, you should know movement plus 3 other functions. Just learn the ones that are easiest for you to remember. We often say that the frontal lobe contains functions that actually differentiate us from animals, from some animal species. Some of what the functions that we call as higher order functions that basically make us more intellectual and more cognitively equipped as a species compared to others. So functions like planning, functions like problem solving, we don't really see in animal species as much as we do in humans. So these are kind of exclusive to us, and these are a part of the frontal lobe. In fact, a part of the frontal lobe called the prefrontal cortex is what is responsible for these functions. Okay, our ability to be intellectual beings who can plan, who can problem solve, who can make decisions is because of the presence of the prefrontal cortex, which is in the frontal lobe of the brain. Okay, so I'll talk a little bit more about the prefrontal cortex with reference to the story or the case study of a guy whose prefrontal cortex was actually damaged. Okay, and this guy was called Phineas Gage. We're going to watch a quick video about him. He was basically a railway. He was working on a railway back in the mid 1800s. Okay, and so this was ages ago. And after an explosion, he worked with iron rods. So basically, after there was an explosion, the iron rod kind of shot through his eye socket, went right through his brain, right through the front part of the brain. And we can see that really clearly in this image here. Okay, that red color stick kind of thing is the iron rod. Okay, it's just like a pole, like a big iron pole, like a metal pole. Okay, that's actually shot right through his eye socket. You can see there, it's gone right through his eye, through the front part of the brain. So you can see behind his forehead, like I said before, that's the frontal lobe. So it's gone right through that frontal lobe. It's literally pierced through it. And it's actually gone through his prefrontal cortex. And remember, I said the prefrontal cortex contains a lot of these functions that are responsible for like emotion, personality, planning, decision-making, all of these really important functions. So we're gonna watch a small video now about Phineas Gage. And Phineas Gage is important, and we call his story, or we call his example, a case study. In psychology, we often look at people in the past. Might be from a few years ago, might be from somewhere as long back as 1840s, but we look at case studies as a way to understand unique examples of things that have happened in the past that have given us extra information or have enriched our knowledge of a specific area of the brain or a specific brain function. Okay, so this is one example. So anyway, I'm just going to pause the recording here while we watch the video. And the video is in the link, is in the PowerPoint slide as well. So you can have a look at that if you want to later on. So let me just pause the recording first. Okay, so what we're looking at, I've already talked about this before, the cortical representation, this idea that, you know, parts of the body that you move around a lot, for example, your fingers, will actually have more space in the brain, or if we want to use a psychological term, we'll have more cortex dedicated to them compared to parts of the body that we use less, for example, compared to our shoulders, compared to our knees, that we don't really move around as much, okay? When I say move around, we're really not talking about just movement as a whole, but we're talking about the complexity or the fineness of movement. For example, if I was to put little specks of glitter on a table and ask you to pick those up, you wouldn't be able to pick up those pieces of glitter with your knee or with your shoulder. You won't even be able to pick it up with your toes. Okay, you'd only really be able to pick them up with your fingers, because your fingers are able to engage in that fine movement to be able to pick those specks of glitter up. If we're looking at things like music, a lot of people play musical instruments, you know, they depend on that function of their fingers to be able to play the guitar, to be able to, you know, play those kinds of instruments, because our fingers are able to engage in very fine movement, okay, compared to other parts of our body. So you would imagine that your fingers will have more cortical space. Now, this weird looking thing here is called a homunculus. It's just a visual diagram or a visual model that basically represents this idea of cortical representation. You can see in the homunculus, the knees are very small, but the fingers and the hands are very big, which indicates that there's more space, or there's a greater representation in terms of those body parts, and a smaller representation in terms of body parts like the shoulders or the knees there, okay? And that's because we use our fingers a lot more every day for fine and complex movement compared to our knees and shoulders. Cool, hopefully that makes sense. You don't have to memorize this diagram, by the way, this little picture here. As long as you understand the concept and what I've explained in that example, that's enough. Okay, we're not going to ask you to draw this or something like that. So that's talking about cortical representation. Okay, and cortical representation applies not just for the primary motor cortex, but also for the primary somatosensory cortex, which we'll look at in a few slides. So something to just keep in mind as we go into the next lobe. The next lobe of the brain, which is at the top of the head, is called the parietal lobe. So the parietal lobe is basically just at the midpoint in terms of your cerebral cortex. It's not all the way at the back, but it's not all the way in the front. It's right in the middle. Okay, so when we're talking about the parietal lobes, the parietal lobe has a major primary function in terms of sensation. Okay, our ability to, for example, detect and experience sensation, particularly sensation with reference to things like taste and with reference to things like touch, with reference to things like texture, all of those things are the responsibility of the parietal lobe. Okay, the parietal lobe has a big role in that. For example, if you're looking for, a new piece of clothing and you've gone to a store and you're feeling the material, your ability to judge that, okay, this material is a lot more silkier than this material is because of your parietal lobe. Your parietal lobe is what allows you to differentiate between those textures. Okay, if you're sitting in an exam hall and you see a little mouse scurrying on the floor next to you, your ability to detect that something's moving there, even while you're doing your exam, is because of the parietal lobe, because the parietal lobe plays a role in detection of movement in the environment, not you moving yourself, but you being able to realize that, okay, there are people moving around me, or there is something that's moving there in the corner of the room. Okay, so that's the basic idea. Also, the location of objects in the surrounding environment is another function of the parietal lobe. So if you're sitting in the classroom and your books are on the other side of the class, your ability to know that, okay, I'm here and my books are there and this is how long it's going to take me to walk there and get my books, that is basically, again, a function of the parietal lobe. So those are three functions of the parietal lobe. Honestly, the parietal lobe doesn't have as many functions as the frontal lobe, but these are the main three that you can talk about. Okay, with reference to sensation, just always specify and emphasize that we're specifically looking at touch and texture. Okay, even though this image shows a picture of the eye, there are separate lobes that specialize in sight and a separate lobe that specializes in hearing. So kind of disregard those two, if that makes sense. Okay, so that's the basic idea behind the parietal lobe. Okay, so just basically the same thing, visual, spatial reasoning, determining where objects are. So we've looked at that already. Sensing your body in space. So if you're standing up and you start, let's say you're standing up straight and you start dangling your hand out on one side, your brain's ability to know that one of your hands is just staying still on one side and the other's kind of dangling in the air is an example of the parietal lobe function. It's our ability to sense our body in space. If I ask you guys to stand on one leg, your brain's ability to know that this is not normal, that you're standing on one leg, that you need to go back to your normal position where both legs are on the floor, that is, again, a function of the parietal lobe. So the parietal lobe is really responsible for detection or object recognition and, recognizing that how our body is moving or how our body is positioned when we're just standing up or in space. Okay, so that's the basic functions of the parietal lobe. Now, what happens when you get damage to your parietal lobe? Basically, depending on where the damage in the parietal lobe occurs and how bad the damage is, a lot of the time you'll just experience issues with reference to like recognizing textures or issues with touch and that kind of sensation. If you've got a lot of like extensive damage to your parietal lobe, and this usually happens because of things like stroke, where the stroke kind of leads to blood vessels rupturing in the parietal lobe area of the brain. This can actually lead to a disorder called spatial neglect. And this is a disorder where the person who has spatial neglect has damage to their right parietal lobe. Okay, remember, right parietal lobe. So they are going to neglect things that are on their left-hand side of the world. So the left-hand side of the world gets neglected. They still see, there's no visual issue there. They can see both sides of the world, but they don't pay attention to the left-hand side of the world. So here you can see this is a normal patient who's drawn a picture of a clock with both sides fully intact. This is the same pictures that are redrawn by a patient who has spatial neglect, where because of their disorder, because of that damage to the right parietal lobe, they have neglected more or less the left-hand side of each of those pictures. So they've only drawn a little bit of the left-hand side of the flower, a little bit of the left-hand side of the house, a little bit of the left-hand side of the clock, and they've kind of not paid attention to the rest of that left-hand side, or in other words, they've neglected the rest of that left-hand side. Okay, just be really careful. Spatial neglect is not a visual disorder. It's not that the person is half blind, okay, because we never said anything about, I even told you guys to cross these two out. We never said anything about the parietal lobe being responsible for vision. That's another lobe of the brain responsible for that. So it's not a visual disorder. It's what we call as an attentional disorder, because the parietal lobe plays a pretty big role in the recognition of objects and attention. and how much attention we pay to it. So it's an attentional disorder, not a visual disorder. So just be careful when you're explaining that in a test or exam situation, not to specify that it's a visual disorder. It's not about the fact that the person can't see the left-hand side. It's about the fact that the person can see the left-hand side, but they just don't pay attention to the left-hand side. They neglect it, in other words. Okay, so far we've gone through the frontal and parietal lobe. Guys, is there any questions so far about the lobes? If there are, just please let me know as we're going through. Now, does anyone remember, it was just a few minutes ago, but does anyone remember the specialized area? We said there's a primary something cortex for the frontal lobe. Does anyone remember what it was? What's the primary cortex in the frontal lobe? Just testing your memory. The motor, excellent, good. So the primary motor cortex was the primary cortex in the frontal lobe. The primary cortex in the parietal lobe is called the primary somatosensory cortex, okay? So this is basically the primary area. It's just like a little strip of brain tissue or brain area that is in the parietal lobe. So this is the whole parietal lobe here in the middle. And the primary somatosensory cortex, I'll just get a different color, is just one strip of that parietal lobe there. Okay, the one in purple there. So it's just one strip there. Okay, so the primary somatosensory cortex has the same features as the primary motor cortex. It has that contralateral organization. What that means is that if I pick up a cup of hot coffee with my left hand and I'm feeling the cup of coffee with my left hand, that sensation of heat will be experienced in my right parietal lobe, or the right somatosensory cortex in my parietal lobe. Okay, so left, if it's your left-hand side of the body or right-hand side of the body, you're feeling something with the texture or the temperature or whatever, then that is going to be on the opposite side of the brain. Okay, so left will go to right, right will go to left. Just remember that it's just opposite sides. Cortical representation is basically the same idea, but now rather than talking about body parts that we move a lot, we're talking about body parts that are more sensitive to sensory stimulation. Okay, so when we're talking about things like if I'm given a hot cup of coffee, the best way for me to feel how hot that is, or the body parts that will experience the heat from that very quickly, are my fingers as I hold the cup of coffee in my hands. If the cup of coffee is too hot and I drink it and I burn my tongue, well, that's evidence for you that your tongue is very sensitive when it comes to sensory stimulation as well. Okay, so those are two good examples of body parts that are very sensitive to sensory stimulation, your tongue and your fingers. Okay, so that is basically some features of the primary somatosensory cortex. I've already kind of explained this in the previous slide, but again, just showing you the homunculus again, which more or less is the same. Again, our fingers, just like they were for movement, our fingers are again sensitive for sensation as well. Okay, sensory and tactile stimulation. Tactile just means things that you can touch. Okay, so tactile refers to like properties related to the sensation of touch. So if you, for example, get a phone cover and it's got like little bumps on it, your ability to feel that those are little bumps and that's got a kind of ragged texture to it is an example of tactile stimulation. Okay, when you stub your toe, when your toe gets caught on something and it hurts a lot, the reason that it hurts a lot is because your toe, just like your fingers, are quite sensitive to that sensory stimulation there from the environment. Okay, when we're talking about sensory stimulation, examples are heat, like a hot mug of coffee; cold, like when your feet are on a tiled floor and it's really cold, you've got to put your shoes or socks on; pain, for example, when someone pinches your finger or your wrist, it might hurt a little bit more than when they pinch your knee, for example; and pressure. Okay, so if someone was to put a heavy weight on you, it might feel heavier when it's on some part of your body compared to when it's on another part of the body. Okay, so for example, if someone were to put a heavy weight on your foot, it might feel like it's a lot heavier compared to if they were to place that on your shoulder or something like that. Okay, so those are just some examples there for us to understand. Okay, now we're looking at the back of our head. We're looking at the back of our brain, which is where our occipital lobe is located. You can remember what the occipital lobe is involved in by looking at the word itself. The word occipital lobe starts with the letter O. So I often say that, you know, just like the word optometrist starts with the letter O, we know that when we need to look at something related to our vision, we go to the optometrist, right? If we need to have an eye checkup or we need to get glasses. Also, the word optical starts with the letter O, and optical is also related to vision. It's related to the health and well-being of our eyes. Okay, so optometrist, optical both start with the letter O. Ocular is also probably a less well-known word, but ocular is also related to your eyes. So all of those things start with the letter O. So that should give you an idea that occipital is thing. And if you look at the word, if you look at the O itself, it kind of looks like an eye. So you can't really forget that it's related to vision. Okay, that's what it is. The occipital lobe is responsible for vision. That sounds funny because we always think of vision as, you know, our eyes are at the front of our head. So why is the lobe responsible for vision all the way at the back? Well, that's just how it is. Okay, and that's because the optic nerve actually connects your eye to the occipital lobe. Okay, so it's not like they have to be closely located to one another because we do have that optic nerve that does our work for us. Okay, anyways, when we're looking at the occipital lobe, the primary cortex that's in the occipital lobe is called the primary visual cortex. Okay, remember the word visual because the occipital lobe starts with the letter O, related to everything to do with vision, related to even looks like an eye. The letter O looks like an eye, okay? So primary visual cortex. Now, the primary visual cortex receives visual information from your photoreceptors. The photoreceptors are located in your retina. They basically detect brightness and color in your environment. And these are located at the back of your eye. Okay, now what happens if you experience damage to your occipital lobe? Let's say someone smashes, you know, the back of your head with, I don't know, something violent. Let's say someone just takes a big hammer and just smashes the back of your head. Okay, the lobe that is most likely to be damaged as a result of that is going to be your occipital lobe. And for that reason, as a result of that violent activity, you may be likely to go blind. Okay, damage to your occipital lobe can lead to blindness because if we say the occipital lobe is the gateway for us being able to see and process visual information, if that gateway is then damaged or injured or experiences some kind of deterioration, obviously we're not going to be able to see with the same, you know, vision that we currently have. So damage to your occipital lobe can lead to blindness. Now, if you get a scenario-based question that says, okay, this person was in a car accident where they were flung out of the car and they hit the back of their head on a nearby street pole, and we ask you, okay, explain or describe one effect that this person may have after they gain their consciousness in terms of what might happen to them. You can then say, okay, the person might experience blurry vision, or if their damage is really intense, they might not be able to see anymore. Okay, so you need to be able to link back the function of the actual lobe to a scenario where a person might have damaged that area of the brain or that particular lobe. Okay. Our ability to visualize things is also a function of the occipital lobe. And this is interesting because people who are blind actually can't visualize things in their mind in the same way that people who have normal eyesight can. So this is really interesting to think about. Occipital lobe also allows us to form visual perception. So let's say you want to redecorate your room. Your ability to think about what your room would look like and visualize what your room would look like if you were to move your study desk near your window, for example, is the function of the occipital lobe. Okay, we're able to form visual perceptions and judgments even before they occur in real life. We're able to make meaning of those through imagining them in our brain. Okay, so that's basically the occipital lobe there. So they can't even use their imagination. Yeah, so it's like they can, I suppose, they can visualize. They can't really visualize things. They can probably think about things that could happen, but they can't like foster up like an actual image of that in their brain if they're blind, which is kind of sad because a lot of the time we do think about things like that. Even when blind people dream, their dreams are less vivid compared to people who have normal eyesight. Okay, so it's sad, but yeah, again, showing you some of the functions of the occipital lobe and how important it is for us. So that's basically what the occipital lobes are involved in. And the last type of lobe that we're looking at for today is the temporal lobe. So the temporal lobe is located above and around each ear. So just take your hand now and just kind of move your fingers above and around each of your ears. That's the area where your temporal lobe would be on each side of your head. So you've got one on the left-hand side in the left hemisphere, and you've got one in the right-hand side on the right hemisphere, okay? The temporal lobes are very close to your ear, okay? If you've got your finger on your head right now, it's very close to your ear, okay? That should give you a clue as to what the temporal lobes are involved in. They are involved in hearing. They are involved in processing of auditory or sound-related information. So your ability to put on your headphones, listen to some music, your ability to log into Zoom every day and listen to, the class or the content that's being discussed, that is all because of the presence of your temporal lobe and the presence of a primary cortex known as the primary auditory cortex. Just like the word visual refers to vision, the word auditory refers to sounds. Okay, we've heard of the word audio. When we talk about audio, okay, audio is basically sound related information. Doesn't have to be music, could even just be someone talking, could even just be a little rustling in the background. Any kind of sound related information that can be detected by our ears is a type of auditory information, and that auditory information is processed by the primary auditory cortex. The auditory cortex is again just a strip of a little strip of cortical area that's in your temporal lobe. You won't be asked to draw it, but just for you to help to visualize that better, that's what it is. Okay, and the primary auditory cortex is really important because it helps us to not just recognize sounds, but to also recognize tone. So your ability to understand that when I'm talking like this, it's normal, and that when I'm talking like, when I'm talking like this, I'm really, really, really happy. And that when I'm talking like this, I'm not happy that no one has submitted their work. So your ability to kind of judge kind of subtle differences in terms of when people talk to you, whether someone's angry at you, whether someone's happy, whether someone's upset, those subtle differences in audio change tone differences, and your ability to detect those is because of the primary auditory cortex. Okay, so that's basically what it's involved in. Okay, some other functions that we can talk about with reference to the temporal lobes are also recognition of faces. Okay, and there's actually a condition that you can develop if you've damaged a specific part of your temporal lobe where you can't recognize the faces of people you know. So you know that that's a familiar face, but you can't put a name to it. So if I were to show you a photo of your best friend, you won't really be able to kind of, know that, yep, that's your best friend. You might say that, okay, that's a person, but I can't really put a label to that. I can't say that, oh, that's my best friend, for example. So your ability to recognize faces of people you know is actually limited as well, because the temporal lobe plays a role in the recognition of faces. The temporal lobe, next year, you're also going to learn about, not next year, sorry, in unit 3 and 4, if you decide to do psychology, at a year 12 level, you will also learn about memory, and you'll learn about the fact that the temporal lobe contains really important structures like the hippocampus, which are actually involved in memory and the formation of memories, okay? And that without structures like the hippocampus in the temporal lobe, you can't actually form episodic memories. You can't remember what your graduation, grade 6 graduation was like. You can't remember what Eid last year was like for you. Those memories would never be formed, okay? And that's why the temporal lobe plays a pretty big role in memory as well. So memory, auditory perception of sounds, recognition of faces, and the linking of emotions to memories because of the role of the amygdala. All of these are some functions of the temporal lobe. So just know the main function, which is auditory perception, as well as maybe two other functions. Okay. This is just a summary table taken from the Unit 1 and 2 Edrolo book, which some of you who are doing Psych 1 and 2 may be familiar with already. Just that summarizes. Look, if you guys are lazy before the SAC to go through, before the test to go through all of these slides, this is probably your go-to. Okay, this will summarize it at a very basic level. I still suggest that you go through all the other slides, but this gives you the basic summary. Okay, I always put the tables in even for my year 12s because I know that Psych can be very content heavy, and sometimes when you're revising at the last minute, it's sometimes good to have a quick summary table that you can refer to. Okay, so bare minimum, that's on the slide here in this table, but more detail is given in the slides that preceded this one. Okay, so that's the basic idea. These are some more memory tips that you can use. You might decide to use them, you might not, really depends, it's up to you. You might decide to make up your own memory tips, that's even better. Functions of parietal lobe you can remember using the memory tip SIP, so sensory information processing, particularly with reference to touch and texture. As well as the position of limbs in space. Limbs are like your arms or your legs or whatever. So being able to understand that your hand is dangling in space rather than being straight at the side is an example. Occipital lobe, I already talked about this one on the slide, the O's, okay, the fact that the O itself that stands for occipital looks like an eye. And for temporal lobe, you've got the memory tip fame, so facial recognition, auditory processing, memory, and emotional attachments to memories. And emotional components of memories basically refers to the fact that if you went to a haunted house when you were really young, okay, and if you went to a haunted house when you were really young and you were really scared, your ability to remember that memory, but to also remember how scared you were, is because of the amygdala in your temporal lobe. Okay, the amygdala is the fear center of the brain, and that's what emotional responses to information is about. Okay, attaching emotional components to your memories. Okay, those are the memory tips for the different lobes. Right, so before we finish up for today, guys, I'll just stop the recording here first.